viewers, you are welcome to another episode of Mathematics Doddle program on GVTV, where we do teach you mathematics. Today is a program that we are wanting to do the topic, which is algebra, and the subtopic of this very topic is lowest common multiples of algebraic expression. Lowest common multiples of algebraic expression. Get hold of your writing materials and let's go.
Mathematics Doddle.
Yeah, welcome back to the class. At the end of this very lesson, I, as your tutor, expect you to be able to find low LCM, that is lowest common multiples of any given algebraic expression. Now, let's start with various examples. So, the example I'm about to start with is to start with the previous knowledge of lowest common multiple. Example 1. Find the LCM, that is least common multiple, of the following sets of numbers. A. 24 and 36. B. 42 and 36. C. 75, 100 and 125. Okay, let's start with this to refresh our memory in finding lowest common multiples. Solution. A. 24. What you need to do is express this 24 as the product of prime factor. As the product of prime factor. And how can you express 24 as its products of prime factors? You can do that by easily drawing a line, a vertical line like this, writing 24. Then start with the least prime factor of 24. The least prime factor of 24 is 2. 2. You now make use 2 to divide 24. 2 in 24 will give you what? Will give you 12. The least prime factor of 12 is 2. 2 again in 12 will give us 6. Okay. The least prime factor of 6 is what? Is 2. You use that 2 again to divide 6. 2 in 6 will give you 3. The least prime factor of 3 is 3. 3 in 3, 1. Now, 2 multiplied by 2, multiplied by 2, multiplied by 3 are the product of prime factors of 24. Okay, so this gives us 2 multiplied by 2, multiplied by 2, multiplied by 3. Now let's move to 36. We want to find the product of prime factors of 36. 36. The least prime factor of 36 is 2. 2 in 36 will give 18. The least prime factor of 18 is 2. 2 in 18 will give us 9. The least prime factor of 9 is 3. 3 in 3 will give us 3. And 3 in 3 will give us 1. So the product of prime factors of 36 are 2 by 2 by 3 by 3. 2 by 2 by 3 by 3. Let's see if truly they are product of prime factors of these given numbers. 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. And 8 multiplied by 3 is 24. And this is 24. So all these are products of prime factors of 24. 2 multiplied by 2 is 4. 4 multiplied by 3 is 12. And 12 multiplied by 3 will give us 36. So all these are products of prime factors of 36. Now the next thing to do is to express each of them in index form. Okay? Expressing this in index form would give us 2 raised power 3 multiplied by 3 raised power 1. That is 2 multiplied by 2 multiplied by 3 in index form will be 2 raised power 3. Okay? And this 3, it is only one we have. So to express it in the index form would be 3 raised power 1. This will be 2 raised power 2. Okay, 2 raised power 2 multiplied by 3 raised power 2. All right, that is that. Now we want to find the LCM. LCM of 24 and 36, okay, will be equal to writing down 2 raised power 3. We are writing down the base with the highest power. Multiplied by, we are moving into the bases of 3. Okay, base of 3. This is 3 raised power 2, this is 3 raised power 1. We are writing down the one of the higher power, which is 3 raised power 2. 3 raised power 2. Okay, and this will give us 2 raised power 3 is what? Is 8. Multiplied by this multiplication sign is this. 3 raised power 2 is what? Is 9. Okay, so the product of these two numbers gives what? 72. Okay, now LCM of 24 and 36 is 72. The implication of this is that 24 is a factor of 72 and 36 is a factor of 72. That is, 72 can be divided by each of these two numbers. That is the meaning. Okay, 72 can be divided with no remainder by each of these given number. So that's the meaning of LCM, the lowest common multiple. That is, the number that can be divided, the lowest number that can be divided by these two given numbers is 72. 42 and 36. So now let's find the product of prime factors of 42. I've told you this will help you by drawing a vertical line with, so writing the number 42 here and think of the least prime factor of 42. We know that 2 is the prime factor of 42. 2 in 42 will give us 21. What is the prime factor, the least prime factor of 21? 3 is the least prime factor of 21. And we write it here to make the division. 3 in 21 will give us what? Will give us 7. Okay? And the prime factor of 7 aside 1 is 7. 7 in 7 will give us 1. Hence, product of 2 multiplied by 3 multiplied by 7 are prime factors of 42. To express this in index form would be 2 raised to 1 multiplied by 3 raised to 1 multiplied by 7 raised to what? By 1. All right. Now 36. The least prime factor of 36 is 2. 2 in 36 will give us 18. All right. Now, the least prime factors of 18 is 2. 2 in 18 will give us 9. Okay. Even we don't need to stress ourselves. We have already done 36 above here. Okay. So the product of the product of prime factor of 36 are 2 multiplied by 2, 3. So let's just pick it here. Okay, I've explained it earlier here in other time. So let's just copy it here and write it. 2 multiplied by 2 multiplied by 3 multiplied by 3. Okay, 2 times 2 times 3 times 3, and I will express it in index form to give me 2 raised to 2 multiplied by what? 3 raised to 2. Okay. Now LCM of 42 and 36, okay, will be equal to, okay, we have base 2 here and we have base 2 here. This is 2 raised to 2, this is 2 raised to 1. We are writing down 2 raised to 2 because this 2 raised to 2 has the higher power. Now multiply by base of 3. This is 3 raised to 2, this is 3 raised to 1. We are writing down 3 raised to 2, 3 raised to 2. Okay. The next thing we are writing is 7, and which is 7 raised to 1. Why are we writing 7 raised to 1? You can look at it. Do we have 7 raised to something here? This could be like 7 raised to 0. 7 raised to 0 is 1, and that 1 multiplied by all this is the same thing. It has not changed any value, anything there. Okay, it has not changed the value of this 36. All right. So now, if my 7 raised to 0 is here, and this is 7 raised to 1, okay, so I'm writing down 7 multiplied by 7 raised to 1 because 7 raised to 1 have higher power than this. Okay, that is it. Now, this will now give us 2 raised to 4. 2 raised to 2 is 4. Multiplied by 3 raised to 2 is 9. Multiplied by 7 raised to 1 is 7. Okay, so the product of all this will be what? 4 multiplied by 9 is 36. Multiplied by 36 times 7 now. Write 7 to multiply it. 7 multiplied by 6 is 42. Write 2, we keep what? 4. 7 times 3 That is 21. 21 plus 4, that is 25. So we write 25. So which means 252 is the product of 4, 9, and 7. So we have 252. All right? Which means that the LCM of 42 and 36 is 252. That is to say, 252 is divisible by 49, by 42, and by 36. Now, the meaning of LCM is that there are many numbers that are divisible by these two numbers. But out of those numbers that are divisible by these two sets of numbers, okay, the lowest number among them is 252. Okay, that's why we say lowest common multiple. So 252 is the lowest number that is divisible by these two numbers. Likewise, 72 is the lowest number that is divisible by 24 and 36. That is that. Now let's move to the letter C. We have 75. We have 100. We have 125. Okay. Now let's look for. Let's come here. Let's see this place. 75. Okay. 5 is a prime factor of 75. 3 is also a prime factor of 25. Okay. But 3 is lower than 5. So let's use 3. And 3 is the least. We are using 3 instead of 5. So 3. 3 in 75. Okay, this will give us 2. That is 3 in 7 will give us 2. We have what? 1. In 15 will give us 5. So we have 3 in 75 to be 25. Let's check it out. 25 multiplied by 3. 3 times 5, that's 15. 5, 1. 3 times 2, that is 6 plus 1, that is 7. Okay, that is that. Now, what prime factor, least prime factor do we have for 25? That is 5. 5 in 25 will give us 5. Okay, then we can finish it up by saying 5 in 5 to give us 1. So this will give us 3 multiplied by 5 multiplied by 5. Now for 100, okay, the least prime factor of 100 is 2. 2 in 100 will give us 50. The least prime factor of 50 is 2. 2 in 50 will give us 25. The least prime factor of 25 is 5. 5 in 25 will give us 5. Then we have 5 in 5 to give us 1. So the product of prime factors of 100 are 2 multiplied by 2 multiplied by 5 multiplied by 5. Okay, that is that. Now for 125, the least prime factor of 125 is 5. 5 in 125 will give us, this will give us 2, and this will give us 5. Okay, let's take it out. 25 multiplied by 5. This will give us 5. We keep 2. 2 times 5, that is 10. plus 2, that is 12. So we have 125. Okay. Now the next we use is 5, because that is the least prime factor of 25. 25 will give us 5, and 5 in 5 will give us 1. So this, the product of these numbers will be 5 multiplied by 5 multiplied by 5. Okay, so these are the product and prime factor of 125. Okay, and to express this in index form, this will be 3 raised to power 1 multiplied by 5 raised to power 2. This will be 2 raised to power 2 multiplied by 5 raised to power 2. Okay, and this will be 5 raised to power 3. Okay, now this can be also be expressed as, since we don't have base 2 here, so I can say 2 raised to power 0 times 3 raised to power 1 multiplied by 5 raised to power 2. Okay, this 2 raised to power 0 is 1. 2 raised to power 0 will give us 1. So I've not changed anything. All this 1 I've written here is still the same thing as this. 1 multiplied by all this will give us all this. We retain this value. Okay, now this is 2 raised to power 2 multiplied by 3 raised to power 0 multiplied by 5 raised to power 2. Okay, it does not change any value. And this will be 2 raised to power 0 multiplied by 3 raised to power 0 multiplied by 5 raised to power 3. So just enable us to have common base in each line. Common base 2, 2, 2, 2, 3, 3, 3, 5, 5, 5. That's it. It does not change anything. Now we want the LCM of 75, 100, and 125 will be the base with the highest power. This 2 raised to power 0, this 2 raised to power 2, this 2 raised to power 0. This is what we are using, 2 raised to power 2. 3 raised to power 0, 3 raised to power 0, 3 raised to power 1. We are using 3 raised to power 1. Multiplied by 5 raised to power 3, 5 raised to power 2, 5 raised to power 2. This is the one with highest. Okay, highest power of base 5. 5 raised to power 3. And this will give us 2 raised to power 2 is what? Is 4. 3 raised to power 1 is 3. 5 raised to power 25. 125. Okay, so the product of all these will be the LCM of this set of numbers. Now the product of all these will be what? 4 times 3 is 12. So we have 1, let me come down here, 125 multiplied by 12. Let's find the product. 2 multiplied by 5, that will give us 10. 0, keep 1, isn't it? 2 times 2, that is 4, plus 1, that is 5. 2 times 2, that is 2. Okay, so now 1 multiplied by 5, that is 5. 1 multiplied by 2, that is 2. 1 multiplied by 1, that is 1. Then we find what? The sum of this number. This will give us 0, 0, 5, 1. Okay, so we have 1,500. 1,500. All right, so the LCM of 75, 100, and 125 is 1,500. That is, 1,500 is the lowest number that is divisible by these 3 numbers. Okay, now the next example will now be finding the LCM of algebraic expression. Example 2. Find the LCM of A, 2A, and AB. B, S square, Y, and X, Z. C, 4A square, 6A, and 8AB. Solution. Now, A, 2A. This is algebraic expression. 2A is an algebraic expression. So what the product, this can be expressed as 2 multiplied by A. Okay, I've told you in the past that when you have a number and a letter joined together, such as, let's say, 9K, okay, it means 9 multiplied by K, the product of 9 and K, that is just it, okay? So when you multiply 9 by K, it will give us 9K. All right, now 2A means 2A, 2 multiplied by A. Okay, and I can express this in index form to be like what I've been doing above, to be 2 raised to power 1 multiplied by A raised to power 1. AB, we have AB. This is A multiplied by B, okay, to mean A raised to power 1 multiplied by B raised to power 1. Okay, now LCM of 2A and AB, okay, will be equal to 2 raised to power 1 multiplied by A raised to power 1 multiplied by B raised to power 1. You know what I mean by that? We have 2 raised to power 1 here. We don't have any base of 2 here. It means that on this line, it's like having 2 raised to power 0. Because 2 raised to power 0 will give us 1. And 1 multiplied by this change the value, doesn't change the value of A multiplied by B. Okay, it's still the same thing. So it's like having 2 raised to power 0 here, which makes this one to be of higher power. Okay, so 2 raised to power 1. Now we have A raised to power 1 here, we have A raised to power 1 here. A raised to power 1 is the value we are writing down, is the highest. So that will be A raised to power 1, and this B raised to power 1 is what we are writing there because we don't have any base of B on this line. So this means 2 multiplied by A multiplied by B. 2 raised to power 1 is 2, A raised to power 1 is A, B raised to power 1 is B. Okay, so the product of 2A and B is what? 2AB. So LCM of 2A and AB is 2AB. That is all. The LCM of 2A and AB is 2AB. It means that 2AB is divisible by 2A with no remainder. Also, 2AB is divisible by AB with no remainder. So, which means that 2AB is the lowest algebraic expressions that is divisible by each of these algebraic expressions. 2AB is the lowest algebraic expressions that is divisible by 2A and by AB. That is the meaning of LCM of 2A and AB to be equal to 2AB. B, we have S squared, we have Y, and we have XZ. Okay? This can be expressed as X multiplied by X. Okay? If you like, you can use that what we'll be using so far by saying that S squared. Okay? You bring S in S squared will give you X. X in X will give you 1. So X multiplied by X. And for what we have done here so far, you can also apply this 2A. Okay? The least, the prime factor, the least prime factor of 2A is 2 or A. Either of the two. 2 into A will give you A, and the next is A in A will give you 1. So the product of 2A, we have 2 times A. That is that. Now, for this, we have Y. This is just Y. Okay? And for XZ, we have X multiplied by Z. Don't forget that this is X raised to power 2. This gives us Y raised to power 1, and this can be expressed as X raised to power 1 multiplied by Z raised to power 1. Okay? So the LCM of, to save time, you have known, you have had the idea, so let us save time. LCM of S squared, Y, and XZ, okay, will be what? Will be S squared multiplied by Y1 multiplied by Z raised to power 1. Okay, to give us S squared YZ. Okay, that is the product of all this. Okay, you can say how is Y raised to power 1 will give us Y. All this will give us S squared multiplied by Y multiplied by Z. And XY times Y will give us S squared Y. And S squared Y multiplied by Z will give us S squared YZ. That is all. Okay? So it means that S squared YZ is divisible by S squared. It's divisible by Y. And it's also divisible by XZ. Question letter C. We have 4A squared, 6A, and 8AB. All right. So for this can be expressed as 2 multiplied by 2 multiplied by A multiplied by A. This 6A will give us 2 multiplied by 3 multiplied by A. This will give us 2 multiplied by 2 multiplied by 2 multiplied by A multiplied by B. In index form, this can be expressed as 2 raised to power 2 multiplied by a raised to power 2. This can be expressed as 2 raised to power 1 multiplied by 3 raised to power 1 multiplied by a raised to power 1. And this can be expressed as 2 raised to power 3 multiplied by a raised to power 1 multiplied by b raised to power 1. Alright? So, LCM of 4a squared multiplied by 6a multiplied by 8ab will be equal to 2 raised to power 3, okay, multiplied by 3 raised to power 1 multiplied by a raised to power 2 multiplied by b raised to power 1. And this will be 2 raised to power 3 is 8. Okay, let me write it like this. 8 multiplied by 3 multiplied by a squared multiplied by b. And the product of all this will be 24a squared b. This is the LCM of this set of algebraic expression. Okay, 24a squared b is divisible by 4a squared. 24a squared b is divisible by 6a. 24a squared b is also divisible by 8ab. That is that. Find the LCM of the following. A 5p 15pq and p squared. B 8x 16s squared and 14x. That is that. A. Question letter A under the example 3. We have 5p, we have 15pq, and we have p squared. Not Peter and Paulo. Okay? Now 5p, this is expressed as 5 multiplied by p, right? This can be expressed as 3 multiplied by 5 multiplied by p multiplied by q. This will give us p. You see it as p squared. Let me just write it as that. Okay? Because it's just only and this will be 5 raised to power 1 multiplied by p raised to power 1. This will give us 3 raised to power 1 multiplied by 5 raised to power 1 multiplied by p raised to power 1 multiplied by q raised to power 1. And this is still the same p squared. Therefore, LCM of 5p, 15pq, and p squared, okay, will be equal to 3 raised to power 1 multiplied by 5 raised to power 1 multiplied by p raised to power 2 multiplied by q raised to power 1. And this will be 3 multiplied by 5, that is 3 raised to power 1 is 3. 5 raised to power 1 will give us 5, is 5. and this is p squared multiplied by q. So the product of all will be 15p squared q. That is that. All right. So 15p squared q is the LCM of 5p, 15pq, and p squared. The last, but not the least, is 8x 16s squared 14x. This will give us 2 multiplied by 2 multiplied by 2 multiplied by x. This will give us 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by x multiplied by x. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Okay, that is that. If you go along by writing your division, that vertical line, and you do that, now pick write 16s squared, you are going to have all this. Okay, try it yourself and you get it. So this will give us 2 multiplied by 7 multiplied by x, and this can be expressed in index form as 2 raised to power 1 multiplied by 7 raised to power 1 multiplied by x raised to power 1. This can be expressed as 2 raised to power 4 multiplied by x raised to power 2, while this can be expressed as 2 raised to power 3 multiplied by x raised to power 1. Therefore, LCM of 8x 16s squared and 14x, all right, will be equal to, this is the base 2 with the highest power, which is 2 raised to power 4. Okay, then we have multiplied by 7 raised to power 1 multiplied by x raised to power 2. For the base of x, we have the highest power of 2, so that's why I'm writing it down here, and it is only 7 raised to power 1 we have here, so I'm writing down here. So we have, this will give us 2 raised to power 4 is 16. We have times 7 raised to power 1 is 7 times s squared. So 16 times 7, I hope you know it's right. Let's do it together here. Let's come here. 16 multiplied by 7. What will it give us? 7 times 6, that's 42. We write 2, we keep 4, isn't it? 7 multiplied by 1, that is 7. 7 plus 4, that is 11. Okay, so which is 112. So we have 112s squared. Okay, so 112s squared is the lowest common multiple of 8x, 16s squared, 14x. That is that. I hope you now understand everything we have done as regards finding lowest common multiples of algebraic expressions. This is your table. Find the LCM of each of the following set of algebraic expressions. A 3t and 9tx. B 4a b 8ab and AB. C 24xy 36xy and 8xy. D 4ac and 12bc square. That is that. Find the LCM of each of the following sets of algebraic expressions. A 3t and 9tx. B 4ab, 8ab and ab. C 24xy, 36xy and 8xy. D 4ac and 12bc square. This is where we are going to draw today's curtain for today's lesson. Ensure you practice them well and join me again next week, same time, same day. I remain Ayobami Ojo. Good day.